Hello, everyone, and welcome to today's webinar on definition-driven API development. Today, we're going to be talking about how teams can streamline their API development using the OpenAPI specification, or formerly known as the Swagger specification, along with some of the Swagger tooling. If you're joining us today, you're probably already developing APIs using Swagger or OAS in your API development, but we really want to share some new strategies and practices for really empowering your team to succeed when developing APIs with Swagger and OAS. As we get started today, I'd love to hear, we had over 2,000 people signed up for today's webinar, and we're really happy with the turnout of people who are here today. Just to make sure everyone can find and use the chat, we'd love if you just share, where you're tuning in from today. We have people coming in from all over the world. So if you wouldn't mind just sharing in the chat there. Yep, so we have some folks coming in from France, from people on the West Coast here in the US, really all around Canada, Texas. Awesome. Well, thank you everyone for tuning in and for letting us know where you're coming in from. We're here at our headquarters here in Boston. And at this time, I'm going to be passing off to Keshav. Keshav will really be walking through today's session, as well as a live demo of some of the different tools we'll be discussing today. And feel free to put questions in as we go along. So let's get started.
Thanks, Ryan, and I hope everyone can hear me loud and clear. So as Ryan mentioned, I'm Keshav, and I will be walking you through understanding more about the definition-driven approach in today's API landscape. So the agenda for today. The agenda for today is really understanding why, first of all, is there necessity for thinking about the definition-driven approach, and to validate that, we actually need to understand the changing API landscape. And from here, we'll start thinking about why, once you understand the changing API landscape, I hope that it becomes clear as to why the definition-driven API development approach matters and why it's becoming such an important part of organizations' API strategy. And from there, we'll take a deep dive into understanding how definitions actually help accelerate design, documentation, essentially the different parts of the API lifecycle, including virtualization, coding, and testing. And finally, we'll be going into a live demo of some of our tools and show you how you can actually perform definition-driven development using the Swagger and the ReadyAPI suite of tooling. So let's go in and understand more about the definition-driven approach, right? So APIs have been around for like a long time. It's not just 10 years ago. It's actually APIs have been around before even the PC was created. But if I want to like take a more microscopic view of this, if we want to start from, say, the early 90s, APIs have primarily been in the SOA-based infrastructure or architecture, right? In the service-oriented architecture, APIs have been around. Then came Salesforce, and in 2000, they kind of like popularized the notion of web APIs, after which e-commerce companies, specifically like eBay and AWS, as well as Amazon, the e-commerce giant, they've all like taken really well to APIs. And finally, of course, we saw how social media really took advantage of APIs to like spearhead the platform movement, which essentially allows developers to come in, and actually third-party developers to come in and start building additional services and application on top of existing use cases and existing services. And with the big smartphone revolution that came about as well, APIs became incredibly useful and popular to not just have great applications, of course, but also to give you that speed and efficiency which you're so used to right now on an iPhone or like in a Samsung phone. Finally, of course, we're seeing how APIs not just like help in just broader end use cases, but they're also incredibly useful to actually accelerate application development, primarily in microservices. And if you want to like split the way APIs have been developed, we can actually take like the 90s to early 2000s approach of APIs, and just look at what the objectives were when you were kind of building APIs in that timeline, in that period of time. And over there, it was more of a very data-driven approach, right? They want if you were a developer at that time, you were primarily building out an API with specific data objective in mind. You wanted to transfer data between different services, and that's why you built out the API. And these APIs were modeled canonically. And all the nomenclature, the nomenclature, the descriptions which you've used were very cryptic, in the sense that they they just use the same nomenclature as you would in a data set, very technical jargon, very industry domain focused jargon, which was not really, it wasn't really built for, I guess, reusability or long-term scalability. And finally, of course, no documentation, and would be lucky if you had good documentation for APIs. Again, because APIs were never actually, as a concept or as a technology framework, there was never an implication of how you could actually help in long-term sustainability of your applications or your services. But now we're seeing there's a big revolution that's happening. And I'll be talking about three important trends that validate why it's so important for you to for you to change your approach towards API development. Um, the first one is companies are now entering the platform ecosystem. We saw that in the social media age, but now we're actually seeing large enterprises, B2B companies, all opening up their products with third-party APIs to essentially transform their products into platforms. And when I say platforms, it's essentially allowing developers, maybe internal or external developers, to add on top of your existing services and extend upon them. Right? When we're seeing so many people actually take up the platform economy. And platforms have actually, if you look at the entire timeline of how much revenue is driven by the internet in general, platforms actually account for the majority of this. They are the major drivers of revenue and economic growth when it comes to the internet. And this is the reason why all of these organizations, or even like small teams, are trying to take advantage of the platform economy that we're living in. And platforms are primarily driven by APIs. APIs are the foundation of the platform economy. And the second trend we're seeing is there's this API first approach. Now, in the API, what do I mean by an API first approach? Well, to understand the API first approach, let's take the example of a monolith. Traditionally, when you build out your application, you would start with understanding what the plan was, and from there you'd build out the database, right? And then after you build out the database, your different backend teams will start building out the business logic, the in finer granular modules, which will eventually get consumed by the front-end clients. And the front-end teams will work on that. Now, here the problem is that one is you have to have so many dependencies between each level to even get the application to its final state. Right, and this is in an era where we're increasingly seeing companies becoming more agile and more quicker and having better go-to-market strategies, and consumers demanding more from companies. This approach is not scalable, and it's not really optimal for speed and efficiency to push features to the market. So in the API first approach, you actually start out with an API layer. Understanding once you have a clear idea of the plan, you actually start out with the API interface and actually mock out for each of these interfaces what is the data that you would be showing or giving by each of these APIs. And from there, once you have your APIs in place, and because you have mock data that gets transferred between each of these APIs, you have your front-end teams and your back-end teams all working simultaneously with each other to essentially build out that service, right? So there's no actual real dependency, because once you have an API or a contract, that actually defines what the arrangement is between the back-end and the front-end team. So in the API first approach as well, it's like APIs are the primary elements of your product and service strategy. And this is actually a real life use case, right? We see companies like Netflix, Facebook, Amazon, all adopting APIs as a primary change agent within the organization to accelerate development and pushing features faster, pushing new updates faster to market. And finally, the biggest trend is the explosion of the API economy. We're seeing that so many organizations are now investing in an API strategy. There are over 100,000 publicly available APIs for consumption, and 85% of enterprises are estimated to enter the API economy, to have invested in an API strategy by 2018. That is just enough reason for all of us to start thinking about how can we best leverage APIs to accelerate our development. So this is not just public APIs when we talk about the platform economy, but it's also even internal private APIs. And the core of all of this is we're seeing these three different trends actually affecting the way we think about APIs, because the modern API is no longer data driven. It's actually consumer driven. Even if you have, it makes so much sense if it's a public API, but a lot of people might be thinking, well, if I have a private API, why do I have to think about this? Well, even if it's a private API, you want to build APIs for long-term sustainability. That means you'll have so many different internal stakeholders all consuming this API. And so they need to have an easy way to understand what this API does. They need to be thinking about how you can discover this API. You need to be thinking about long-term sustainability of how this API touches on various parts of your system. So it's not data driven, and it's not built for short-term goals. It's built for long-term consumer driven tactical strategy that the modern API tries to satisfy. The modern API is also staged for self-service development and consumption. So in an ideal world, you should give an API to someone, you should hand over the API to someone, and they should be in enough position to just look at the API and reach success with that API. The modern API is also built to enable speed of updating and maintaining not just your own internal applications, but also allowing third-party services to consume it. And finally, the modern API has a common vocabulary. You have so many different programming languages in the world that are coming up. JavaScript is always something new happening in that world, right? There's so many different technology stacks available. Your APIs, if you're building it for long-term sustainability, should not impose limitations for different people consuming it in terms of technology stack. So if I built a service in PHP, I should not be imposing restrictions saying, hey, the other person should also be consuming this in PHP for them to be successful. It has to have a common vocabulary of consumption. So the modern web API is just based on reusable HTTP standards, and it's built for consumer demand and for self-service consumption. And this is why the definition-driven approach is so important. See, the definition-driven API development approach is essentially putting the API's definition or the contract first before any other part of the API lifecycle is started. And we use this definition, which we created, to accelerate every single part of your API lifecycle. And it's very interesting to see how just having this one primary element in place before you start your work, which is the definition of the API, the contract of the API, you will actually be driving the implementation of the API. You will actually make it's actually much easier to implement the API once you have the definition in place. It becomes so much easier to maintain the API, especially if you want to build APIs that last for like a long time. And finally, consumption. There's no point building something if no one wants to use it. You will actually have having a definition-driven approach puts the consumer first and foremost in your strategy, and it makes sure that they have an optimal experience when consuming your API. So we have a common vocabulary. We need a common vocabulary for the modern REST API world, and that is the definition. And the definition has to be machine and human readable, meaning both humans and machines should be able to understand it. Humans understanding it, machines like tooling ecosystem should be able to integrate with it. And finally, they have to be language agnostic, right? No restrictions on technology stack. And what we're seeing is the OpenAPI specification, which is now the world standard for defining and describing RESTful API interfaces, is the answer to this. The OpenAPI specification, which is formerly called a Swagger specification, is seeing such widespread adoption in the API world. So many industries are adopting this, and we're seeing this in real world examples as well, which we'll be talking about moving forward. And the OpenAPI specification, once you define your API, once you have a definition in place, actually opens up a world of possibilities. From the definition of your API, you can actually go all the way from designing the interface to implementing the API's backend, to virtualizing the API, checking the API for quality, creating amazing documentation, and finally deploying it to the right runtime environment for your end consumers to find and consume it. Right? So the OpenAPI, the specification, the definition, the contract allows you to do all of these amazing things. And when we're seeing like there's real world tangible implications of adopting the definition-driven approach. One is, once you have a definition in place, you actually reduce interdependencies between technology stacks, between services, between systems, between teams, allowing all of them to work at their own pace once you have a definition in place. Because remember, the definition is nothing but the contract that binds the servers and the clients together. Secondly, you will have faster development and delivery. This is kind of a byproduct of the first advantage. No limited interdependencies, allowing you to do faster development and delivery. Of course, with how the definition, from the definition, you can actually auto-generate a lot of the different parts of the lifecycle, including documentation, including development of code, including test cases, including word servers, right? So you actually, from the definition itself, because of how machine readable it is, you can actually abstract all of those different operations. You can easily expand to different interfaces, clients, and views. Especially right now in 2018, there's so many devices, so many different front-end applications which are consuming your services, right? So with the definition-driven approach, it actually becomes much easier to expand to different interfaces, clients, and views because you have an API in place. And APIs essentially are just data. It's just data, and you can use that data across different clients. And all of these three advantages relate to faster development of your applications, right? So it's not necessarily third-party public APIs as well. They're all related to your internal applications. And finally, of course, if you want to think about third-party public APIs, because you're putting your consumer first and foremost in your API strategy, when you adopt the definition-driven approach, they will actually have a great experience using your API that actually can tangibly lead to new revenue channels and growth of your other services and products. Right? So the definition-driven approach is a proven way for you to actually achieve all of these different advantages. And as I said, it touches on every single aspect of your API lifecycle, all the way from planning to deployment. So definitions touch every phase of the lifecycle. And it goes from the definition, you can design, you can document, you can virtualize, you can code APIs, and you can test APIs. So in the next part of the webinar, I'm going to be talking about how each of these different phases are accelerated using the OpenAPI specification. So let's start talking about how the OpenAPI specification can actually help you in your design. So designing is important because designing an API, even before anything is started, actually forces you to think about a couple of things. Right? One is, it's very important to start thinking about what is your business's taxonomy. It's not a technology thing, right? Remember, like we're moving away from a data-driven approach to a more consumer-friendly, consumer-focused, business-friendly approach. So we need to understand what is the organization's business taxonomy. What do I mean by this? Well, let's take, for example, if say, for example, you are a payment provider, like say PayPal or Braintree, right? In that case, your business taxonomy is looking at all the different bounds of your various services within your technological infrastructure that tie to a specific business. So you will have, say, for example, a payments, an invoicing feature service. You will have a client ID service, you will have a credit card service. All of these different things are the bounds of your business taxonomy. And so now when you start thinking about, well, okay, this is my business taxonomy. Now I have to create a new API. Instead of going in and developing it further, designing the interface actually forces you to think, well, what are the different resources which I'm going to be exposing that touches on different aspects of my business taxonomy? And then you can actually you'll start to understand the intricate ways in which there are relationships that form between these different systems. So once you've identified this, you actually start to think about how can this API bring tangible outcomes to my internal processes. What is the tangible outcome it provides to business? And finally, what is the tangible outcome it provides to customers? Designing the interface actually forces you to do all of these different things. And that's a great thing to do because at the end of the day, remember, your APIs drive your internal and external strategy. So this is an example of a design, right? This is in OpenAPI 2.0 or Swagger 2.0. And over here, notice that it's again, this is the designed API and there's no code involved in this. It actually just talks about what is the API description, what is the high level information you can provide for this API, what are the various requests associated with it, and finally, what is the responses for every single for the operation over here. Right, so it's a simple design. Of course, this is just a simple API example. But as your API becomes more complex, as you add more resources, designing the interface becomes a little more challenging, but also leads to long-term positive ramifications. The other big advantage of designing is that it keeps all the internal stakeholders aligned, right? So if, say, for example, the green bar you see on the screen is the design of the API or the RESTful interface, as we want to call it, um, you will actually see that this actually keeps all of the internal stakeholders, from the testers, the developers, and the architects and technical writers, all of them aligned and in sync on what the API does. Because remember, the contract defines what the API is. It talks about the requests, the responses for every single resource. And so there's no second question. There's no big questions in people's minds. They know what this API does. So it keeps all of them in sync and helps actually communicate, keep all of them have, and helps actually communicate the value of the API to the stakeholders as well. So a real life example is PayPal. PayPal actually has a system in place internally where they actually go through a stringent review process whenever you're building a new API. They first start with, anytime someone wants to create a new API, they go through an alignment exercise where they look at the business taxonomy and they determine where the API fits into that. Then all the different internal stakeholders have to sign off on that, after which they go about designing the API first. So they design the API interface, and only then, once you've again verified the design with all the technology stakeholders, only then do you actually develop and deploy it. And this is something which is used by PayPal. So we've spoke about how definitions actually touch the design phase. Now let's start thinking about how definitions can actually touch your API documentation phase. So we know that the API definition can actually keep all your internal stakeholders in sync, but actually from the definition, you can actually create documentation that allows your end consumers, the little people icon you see on the right, to actually hit the API and consume the API. So when we say documentation, right, and I'm pretty sure a lot of people on this call have heard of this. There's like very popular open source documentations like the Swagger UI, right, which is very popular. It's like if you go to pet store, if you Google for pet store and API, you'll know what I mean. And there's like some great advantages when it comes to documentation, auto-generated documentation from the definition. One is, from the definition itself, you can actually auto-generate beautiful interactive documentation. This means your technical writers aren't spending too much time, for example, working on making it great, working on updating the documentation. You actually can get this out of the box, auto-generated from the API definition. The documentation, the Swagger UI specifically, of course, because it's open source, can be hosted anywhere, and it's fully interactive, right? So you can actually interact with the documentation itself. You can understand what the API does without actually having to integrate that into your own code base to figure it out. So the Swagger documentation actually allows you to do that from the definition itself. Another example which is not mentioned over here is how documentation, the auto-generated documentation, can actually help in keeping your API consumer-friendly view updated as well. Because remember, APIs are bound to change. Your development, your code base will always keep changing. But before the Swagger ecosystem came about to generate documentation, your development teams had to be so in sync with the technical writing team. Every time the code base changed, the technical writing team would have to figure out what are the big changes that have happened so that they can go in and update the documentation. However, now with, say, something like auto-generated documentation from the definition, instead of the development team going in and changing their entire application, instead of the development team communicating all these new changes every single time to the documentation team, they can always update the definition itself, which will in turn update the documentation. So you have a better feedback loop when actually generating documentation from the definition, when you actually design the definition first and only then go into documentation. And we have some popular examples, right? So this is, for example, the Swagger UI. The Swagger UI is actually the documentation for the Marvel API. It's used by IBM. So it's used by a lot of people. In fact, the Swagger UI and the Swagger editor, a combination of the open source tools, are downloaded once every 7 seconds. And that's a lot of download volume. And we're seeing this traction speak volumes about how different companies are also adopting a definition-driven approach as well. So now that we've spoken about design, then we've spoken about documentation. Now let's start thinking about virtualization. So virtualization is not a new concept. It's been around for a while, but it's kind of becoming a big important piece in the API world. So what do I mean by virtualization, right? So let's take the example of the fact that you're building an application and you're building an API as part of that application. Now, say in this case, this application, this API which you're building, actually interacts with the Google Maps API. Um, Now, the Google Maps API, even though it's public, they have rate limited their public API. Now, in your system, when you actually want to, when you're still in the development phase, you want to make sure that you're testing these APIs for under high load. So you cannot keep hitting the publicly available Google API, because remember, they have a rate limit, and they will essentially be charging you once you hit that rate limit. So this is just an example, of course, where now instead of using the Google Maps public API, you can actually virtualize the data which was supposed to be hitting Google Maps. Instead, you can actually have that data locally stored using virtualization, and allow you to actually perform some great comprehensive tests to your existing API. The other, of course, example is, instead of waiting for the backend team to go in and build out the entire backend logic for the front end teams to start consuming them, you can actually have mock data once your definition is created, so that different teams can actually start working on this without any dependency. So this is just an example of service virtualization, and it's not just seen in APIs. Of course, it's seen all across the board, as I'm showing you: devices, databases, networks. It's all over the place. So, as I kind of alluded to this, but from the definition itself, you can actually virtualize all the different operations and the data points which your definition actually specifies, from which your internal stakeholders, like your developers, your testers, they all can start understanding what the API does and start working on their different job functions. The developer, say for example, the front end developer, he or she knows exactly what the data is supposed to be returned from that API, so that they can start working on their front end clients. The testers, they can understand the requests and responses. They can get the dummy data and start writing test cases. So that's just an example. So it kind of minimizes dependencies and allows them to develop a great API. There's another example where from the virtualized API, instead of waiting for the entire application to be created, you can actually send that to a consumer. Especially third-party partner-based consumers who who kind of have like a revenue arrangement with you, and you can get early feedback from them on saying, hey, does this API fit your needs? You can get that early feedback. You can iterate on that feedback in a very agile way and build out a solid API which everyone loves. So virtualization has great advantages for your internal stakeholders as well as your external third-party partners. And advantages: reduces dependencies between teams. It allows you to work in parallel, because once you've reduced any dependencies, different teams can actually start working together simultaneously without much dependencies between them. And finally, of course, faster prototyping. Since everyone is aligned on what the data is supposed to be returned from the responses, they can all start working simultaneously, and that ensures a faster go-to-market for your API as well. SmartBear specifically has a product called Service Virtualization, Service Pro, that allows you to do all of these things, create virtual services really fast, either locally or on the cloud itself, and really virtualize APIs and databases with almost little to nothing configuration. Right? And primarily from the definition, we're talking about primarily how these tools can actually do it from the definition itself. So from your definition, because you've specified all the requests and responses, there's minimal configuration because that's already been done in the definition itself. Now let's talk about how definitions touch the development phase of your API lifecycle. So code generation is something that's become incredibly popular as well, especially with tools like the Swagger CodeGen, which is one of the most popular tools in the Swagger ecosystem. So from the OpenAPI defined definition of your API, you can actually generate server stubs and client SDKs directly. What do I mean by this? Well, let's take, for example, you have your OpenAPI specification. From here, using, say, a code generating tool like Swagger CodeGen, you can actually generate server stubs in over 30 different languages, which your developer, your internal stakeholder who builds out the API, who can then use that server stub. And instead of worrying about any of the boilerplate code, they can focus only on the business logic. Because what the code generator does, it abstracts all of that manual routing, the configuration, the, essentially all that boilerplate code which people have to worry about, and it gives you this nicely packaged code base, which your developer can then go in, focus just on the business logic, and build out a solid API. It minimizes so much time, reduces so much time, and minimizes the effort. And then we have the consumer. From your code generation, you can actually also generate SDKs. SDKs is a big problem. I've heard so many clients who tell me how incredibly hard it is to build SDKs in so many different languages, client SDKs specifically, because there's so many different programming languages and everyone has a different need. So with the Swagger CodeGen project, you can also auto-generate SDKs in over 40 languages, which is a large amount of programming languages, which the consumers can then use. Again, all of this is open source, so you can actually go in any time and start using them. So the advantages of Swagger CodeGen, of course, or just code generation from the definition, is no wasting time on boilerplate code, right? Once you have the definition in place, from the definition itself, you can auto-generate the server stubs or the client SDKs. No wasting time on boilerplate code. Let's just get straight to the point. Let's focus on the value of the API and not spend time on manually configuring that API's routing. Faster prototyping. Get to your value as soon as possible. And finally, out-of-the-box SDK generation for easy consumption. You can ensure that you have SDKs right out of the box, which your end consumers can then use to start consuming that API, integrating that into their own applications, and essentially makes for a great developer experience as well. And the tool that supports this is the Swagger CodeGen project, which you can find on swagger.io. And finally, let's touch on the testing phase of the API. So again, from the definition, once you've defined the requests and the responses, you can also generate test cases directly from the contract itself. And when I say contract, of course, I hope people understand that's also alluding, I'm using definition and contract interchangeably. So the definition essentially defines what the API is supposed to do. So let's take the example of, once you have the definition in place, you can actually import that into a testing tool, like for example, ReadyAPI. You can generate your test cases because again, operations are already defined. You can generate your test cases. But what's interesting though is there's a play of refactoring over here. As I mentioned, right, especially in an agile environment, your API code is going to be constantly changing when it's in beta or when it's not ready in production yet. And in that case, every time there's a change, you can actually refactor those changes directly because the contract gets updated first. So once your contract or your definition gets updated, those changes can automatically get mapped or pushed into ReadyAPI, which you can then use to generate test cases from. So again, abstracting a lot of the hard work which you would have otherwise done without a definition. Without a definition, again, testers would have to understand what are the changes that have been made. They'd have to talk to developers and distributed teams. That's a whole other problem altogether. So this way, the definition makes sure all of these stakeholders are in sync, make sure that they know what are the changes that have been updated, and just ensures for a speedy and efficient process. So advantages of testing from the definition: reduces time to market by generating quick tests. It easily ties back to the development process, so you can actually easily refactor changes anytime anytime there's been updates. And finally, it actually mitigates risk. This is kind of obvious because while you're doing quality testing, especially if you have a public API in production, you want to ensure that it doesn't actually introduce any breaking changes to your production applications. We do have a tool like ReadyAPI. ReadyAPI is a API testing tool, a suite of tools by SmartBear software. Some of you might have heard of SOAP UI, which is one of the world's most popular automated REST and SOAP API testing tools. That's actually part of the ReadyAPI suite of tools. And a lot of developers use this. And we're seeing a big use case of these developers and testers is to actually test OpenAPI or Swagger-based APIs. So we're seeing a lot of adoption in the definition-driven approach as well. So we've touched on all different parts of the lifecycle now. We've spoke about how definitions touch design, documentation, virtualization, developing the API and testing the API. Of course, there's also monitoring and also deploying the API. That's for a bigger webinar. We're not going to be focusing on those specific phases in this webinar. So I hope in the past 30 minutes or so, we've kind of understood the value of having a definition before you start your development, your testing, your deployment, and your virtualization, right? So that we call that approach the design first approach, where you're building out a brand new API and you're starting from the definition first before you do any of these other phases. You're designing that API first. But what happens when you have all these existing legacy APIs which don't have a specification in place? You have so many old APIs, RESTful APIs, which don't have a standard already defined. So that we call as the code first approach, where you have the existing applications code, APIs code base, and now you need to start thinking about how to generate the definition so that moving forward, you can just update that. You can focus on a definition driven approach in that specific scenario. So for that process, we actually also have a tool called Swagger Inspector that allows you to generate the OpenAPI definition from the existing API. Swagger Inspector is completely free. So again, this kind of ties into Swagger's policy of open source as well as free tools, as well as some commercial tools. But primarily, we want to make sure that our community gets the best out of all the things that we have to offer. So it's an easy to use online cloud-based tool to validate an API. Also, while you're validating, generating a corresponding OpenAPI definition. So you can actually, on the cloud itself, you can actually generate the OpenAPI documentation or your definition from existing APIs which don't have a definition in place. Right? So the core value, of course, is to not just ensure that the API's work as intended, because again, you're validating the API, but you're also simultaneously generating the definition, which in turn leads to user-friendly documentation. So we've spoken about the OpenAPI, which is the specification, right? So that's the specification, that's the definition that essentially defines what your API does, which leads to all this, which leads to the acceleration of different parts of your lifecycle. Swagger is the set of tools, right? Swagger was a market leader in the RESTful world when it created the Swagger specification. We donated it to the OpenAPI initiative just so that, and renamed it as the OpenAPI specification so we could standardize this across the world. And now Swagger is a broad sort of tools. We have a broad suite of tools all the way from open source tools like Swagger UI and Editor, going to free tools like Swagger Inspector, and to commercial tools like Swagger Hub. So we want to cater to a broader set of audiences and make sure that we can help you as best as we can to accelerate your API development. So of course, I've spoken a lot today, and thank you so much for bearing with me so far. So now let's actually see some of these things in action. Right, so the best way to actually, and this is just a plug for what Swagger Hub is, right? So as I mentioned before, Swagger Hub is an API design and documentation platform. It's built for teams. So you can actually design interfaces and actually tie that definition into different parts of your lifecycle. And when I say different parts of your lifecycle, I actually mean it, because we actually have out-of-the-box integrations with source control hosts, API development platforms, API management platforms, webhooks, all sorts of things. So it really helps teams, especially enterprises, scale their API development. So the best way I can actually showcase all the things which we mentioned of the value of the definition-driven approach is by taking a demo scenario. So in this example, let's say that we in the fictional Star Wars universe, in the galaxy far, far away, long time ago, we actually work in a company called the Dart Corporation. And the Dart Corporation has been around for a long time, for hundreds of years. They have a mixture of legacy APIs. Specifically, there's a Star Wars API which we found online, and we also, moving forward, we want to build modern APIs for. We know that there's a changing ecosystem, and we want to build more modern web APIs. So our objectives really is to generate the definition from an existing legacy API for the Death Star. And finally, for moving forward, we also want to create a new API that allows you to get information from, say, all the employees of the Death Star. So it's two specific objectives, all of which tie into the definition. So in objective one, which is having a legacy API, we will be actually taking an API and using Swagger Inspector, we will be generating the definition. And in the definition-driven approach, we will be taking for the new APIs moving forward, specifically the HR API, which I showed in the previous slide. We will be using Swagger Hub to design the definition, document the API, and simultaneously generate the code. And we will actually push that API definition into testing as well as virtualization platforms. So let's get started right now. So I hope everyone can see my screen. So this on my screen, you will be seeing the Star Wars API. So you guys can actually check it out. It's a pretty cool website called Swappy, Swap API, Star Wars API, and essentially you can explore the Star Wars universe using this API. So let's say, for example, so you can go to inspector. And inspector, as I said, is our free tool over here. And then this is where we can actually go in and see inspector. And in inspector, what I'm going to be doing right now is I'm going to be, first of all, exploring this API. What does this API do? What does this endpoint do? And finally, my objective is to generate the definition. So for the Star Wars API, I'm going to be generating the definition. So this is the resource, and it's, if I'm correct, it's people slash it's people slash, I'm going to select 4 because 4 gives Darth Vader, who happens to be the CEO. So there you go. 4 is 4 is Darth Vader's information. You get all of his information, height, mass, etc. And from here, I can also, for example, get information about planets, right? So if I do planets, I can actually get the Alderaan planet over here. And what I can do is now you can see from my history, I have a clear path on all the points in my history, right? So from here, I can actually go in and add them to a collection if I want to. Or create an API definition. Oh, I realized I didn't log in. Right. So over here, I can select this, and from here, I can add them to a collection. So I can do create a new collection and .go. And from here, I can select this and create an actual API definition. So what I just did is based on my requests, which I've done from my history, I've created a collection, combined them together, and then with just a click of a button, I'm now creating a definition which opens up in Swagger Hub. And so I can say Star Wars example, change this under my name, and import. I'm now in the process of importing my definition. And there you go. We actually just generated the API definition from that endpoint. It combines both those requests together. And so with just a click of a button, we just did this. Traditionally, how you would have done it is by using something like open source tools, where you have to add code annotations manually to different parts of your API. Over here, you're just abstracting that entire process. So this is Swagger Hub, by the way. I'm going back to Swagger Hub over here. Right, and this is the Swagger Hub interface. For those of you unfamiliar, Swagger Hub is the API design and documentation platform, which is built by the same team behind Swagger. Over here is where you can actually access all the APIs which you've either created or which you've collaborated on. And on the left are the organizations or teams which you belong to. If anyone's interested in taking a deep dive into Swagger Hub, we do a regular Swagger Hub 101, which is, I believe, bi-weekly. But for now, in this specific example, let's understand. It looks like my screen is stuck. create a new API. Yeah. And over here, I'm going to be, say, creating an API in version 3.3. Right. So let's do a blank API. And version is 1.0.0. The title of this API, I'm going to be setting it to API and giving it a basic description, right? You can set the visibility to public over here. Auto mocking, you can actually mock from the definition itself. Swagger Hub supports that. We're going to set that to off. And finally, I'm going to set the organization to SmartBear software. And this just now takes me into the blank page where I can start defining my API. So notice that, of course, over here on the left is where I start designing the API, and we're designing this in the latest standard, which is OpenAPI specification 3.0. We also support 2.0. And on the right is where you can start visualizing the API. So over here, if I want to start typing, I can actually start typing the endpoint. So I'm creating an HR API database. And notice that there's actually an autofill. So it actually intelligently suggests what I need to be typing the next sentence, and actually gives me all that information, which is pretty cool. Right. So notice that as I'm typing as well, if my API is not validated, is not correct structurally based on the OpenAPI standards, I actually get errors on the right as well, and I can actually see that there's feedback given by the editor that allows me to understand what this API is supposed to do. So over here, I'm now going to copy paste instead of so I know we're short of time, so I'm just going to be copy pasting the entire API. Click save over here. And for those of you interested, this is a public API, which you can go to Swagger Hub anytime and access right now. And notice that, I have one resource called collection called employees, and I have two operations under them, get and post. Right. So over here now I can do a couple of things in Swagger Hub. One is, we want definition-driven approach is all about communication. So on Swagger Hub, you can actually invite different teams. So we have architects, and again, Swagger Hub is a collaborative platform which you can invite people into your teams from the settings of Swagger Hub and put them into different categories with the right permissions. So over here, I'm inviting architects, developers, documentation writers, the governance team, and I can give them different permissions. For example, the development team, I don't want them to touch the definition. I would rather have the architects touch the definition, and the development team can only give me feedback using the Swagger Hub comments feature, or they can essentially view the API as well. And of course, they can go in, they can give us feedback anytime. Please add new edits. Right, so you can actually give feedback using Swagger Hub's comments feature. And we've just added all of those different team members to Swagger Hub. So from here now, let's start going into the documentation phase, right? So automatically, Swagger Hub, from the definition, you're generating the Swagger UI. This is the interactive, beautiful documentation, which you're seeing over here. And you can actually try it out depending on whether or not you have a backend service already configured. So you can actually execute requests in the definition, in the documentation itself. So this makes it completely interactive. And again, it's coming automatically generated from the definition. You can also generate code. So we have client SDKs as well as server stubs. We're pushing that client SDKs and server stubs in over 30 different languages. You can see that over here in another example as well. Right, so over here, if you go over here in the Star Wars example, you can see that we have over 30 different types of client SDKs and server stubs, which you can click and then generate, which automatically generates the code for you. Let's go back to the SmartBear HR API. So we've come from the plan of the API. We've designed the API using Swagger Hub's design interface. We can actually automatically generate the documentation, which you can host as well, either on the cloud on Swagger Hub or within your own internal servers. And we can also generate code for Swagger Hub from Swagger Hub, either from for client SDKs or server stubs as well. Now from here, what we can do is actually import this API into the testing platform called ReadyAPI. So remember, definition-driven approach is all about accelerating different phases of the life cycle. So from your definition now, let's start generating some test cases. So this is ReadyAPI. I hope everyone can see my screen. And from here, I'm going to click on New Project, description file. Specifically, it's an OpenAPI definition. We import it. And from here, what I'm going to do is get the Swagger JSON file. So we're going to be hitting it to the Swagger Hub public API. So I'm just going to change the URL. And there you go. I just imported my project, and this is the Swagger Hub SmartBear HR API, which I just created. And you can see all the different resources and endpoints which I've just created from the definition itself, right? So there's the get method and the post method, and I can expand on that, and I can see all of them over here. So from here, I can generate test cases. So I can go over here and click generate test suite, and I can generate my test cases automatically from my resources, from my operations. Or I can also generate a vert, right? So I can actually virtualize my endpoints. So let's do this. I just generated the vert over here. And now I'm in service V. You can see that over here. Let's see. And from here, what I can do is using service virtualization, I can actually start virtualizing my API's endpoints as well. So again, I took a definition, I've developed the API using CodeGen, I've documented the API using the Swagger Hub visualization. I'm now putting it into ReadyAPI to generate tests, and now I just generated a virtual instance. So now over here, what I can do is I can base, there are two operations over here, get and post. I can actually go in and edit my responses. So let's take an example over here. I'm adding some dummy data. So over here, I'm adding some dummy data, JSON data. I've just added a hello world dummy JSON data, right? And now what I'm gonna do is I just started the word server. I just started my word. And it tells me that it's available on localhost 8088. So let's go back over here. Let's do 8088. And we know that the endpoint is employees, right? Because the employees is the endpoint. And there you go. You're actually now seeing live the dummy data, which I just created in my virtual instance. So what I just did is I took a definition, I took a plan first. We then went into Swagger Hub, generate the definition. From the definition, we added some collaborators on Swagger Hub, gave them the right permissions. Let me just open up Swagger Hub so you guys can see. Yeah, I gave them the right permissions to and added them to my API. I then showed you how I can use the Swagger UI. I hope everyone can see my screen for the Swagger UI, where you can now go in and interact with various endpoints. We then generated code using the Swagger CodeGen. And again, all of this is done in OpenAPI 3.0 on Swagger Hub. And from here, I'm taking this definition and importing that into my testing platform called ReadyAPI, where I generate test cases as well as virtualize the API's backend. So I'm actually giving some dummy data so my backend team as well as my front-end team can start working on this API. This is a very, very high-level demo, of course, but my hope is that it shows you the power of how definitions can be used in every single part of your lifecycle to really abstract a lot of that information or the configuration which you would be doing in those phases otherwise. Of course, like from Swagger Hub, you can actually, this is just version 1. So you can, as your API updates, you can actually add another version, like version 2.0, and do the same exact thing. right? You can make changes to this API. You can refactor those changes automatically in ReadyAPI. So this way it ties into the entire life cycle of your application. So we've reached the end of our webinar right now. Let me go back over here. So my hope is we've come a long way. We've touched on the importance of definition-driven development, and we see how like real-world applications can actually benefit from that use based on the 3 trends which we've seen. And also, I've showed you how the definitions can touch on every single part of your life cycle. Finally, we took a deep dive, saw how the definitions can actually help in real life using with the demo scenario which we set up. And finally, towards the end, we actually took a definition and actually went all the way till the testing and the virtualization phase. We also showed you Inspector, which allows you to generate OpenAPI documentation from existing APIs. So now I'm going to hand it back to Ryan and ask if you have any questions.
Sure. Thank you so much, Keshav. That was a great presentation. And as Keshav said, I know we covered a lot. I know some people earlier on in the webinar, maybe who are a little bit more advanced, were looking to get right into the practical hands-on stuff. But hopefully, you know, as we got into it, you really found some real value. So we appreciate everyone tuning in.